Hi guys, welcome to the Elm tutorial part 6. This will be our final video. As always, I'm Tensor from the Tensor Programming blog. Today we're going to create a calculator using Elm. The reason we're going to create a calculator using Elm is because it's a very good program to showcase Elm's strengths as a functional language. Now note, we do have a style sheet here. This is a style sheet I created beforehand. You can download that from the GitHub if you want to follow along. Okay, so let's get started. First we need to install the packages. Alright, for this program all we need is the core, so we just installed the core library. Now let's make our imports. So these are the imports that we're importing into our project. As you can see, we're exposing HTML because we need to make some HTML elements. We're using HTML attributes because we're going to manipulate that HTML. We're using the HTML.app because it makes things easier. We're using HTML events because we need on-click events for our buttons. And we're importing the string library so that we can manipulate strings. Now I've divided our program into 3 different parts. This is because we're not going to be using a subscription part in this program. Let's start with our main function. So here's our main function. As you can see, we're using the beginner program. One second. As you can see, we're using the beginner program function. That is only because we have a model, a view, and an update, and we're not using subscriptions. So let's start with our model. So first we're going to make a type alias of calculator. Inside the type alias of calculator, we're going to have a record, and that record is going to contain all the different functions that we're going to use to actually change things in our calculator. So we're going to have add, subtract, multiply, and divide. And as you can see, here's our add function. It's taking in 2 floats and outputting a float. And here's our completed record. We have add, minus, times, and divide, and all of them take in 2 floats and output a float. The reason we're using floats for this type here is because we want to be able to add decimals ourselves, and we want to be able to deal with decimals inside of our calculator. So let's actually write the calculator function. Our calculator function, of course, is going to be of type calculator. Inside of our calculator function, we're going to have 4 anonymous functions. Each one is going to correspond to one of the operators here. So, as you can see, our add anonymous function just takes in 2 variables and then adds them together and returns them. And there we go. That is our calculator function with add, subtract, multiply, and divide. As you can see, our calculator function just contains 4 anonymous functions, each one bounded to a field of the calculator. And we're going to be able to invoke these functions through our update. So now let's write our initialized model. First, of course, we need to write a type alias for the model type. So this is our type alias for our model. Inside of it, we're going to have a display, which is our display. When we put stuff into our calculator, this is where things are going to output. We're going to have our function, which is essentially one of these operators. So we're going to pass one of these operators in, and it's going to fulfill this field. We're going to have a save value. Now our save value is basically the value that we enter in first. So when you use a calculator, for example, if you're adding 3 plus 2, you click the button 3, and then you click the plus sign, and then you click the 2. Well, we need some place to save that 3 value. So this is basically how we're doing it. We're going to put it into this field of the model. Our append value is basically a flag. Append is basically going to let us add more numbers to a number. So for example, we can have multi-digit numbers, and we can have decimal numbers if append is true, and if it's false, then we can only have single-digit numbers, etc., etc., etc. We're going to do this for 2 specific reasons. One, so that if we hit the decimal sign when the field is blank, it will actually show 0 point whatever. And then the other one is so that we can actually deal with 0, so that if you type in 0 and then you type in numbers after it, it will not append those numbers to 0. So let's build the initialization for the model. Our init function is going to be a model type, of course. So here's our initialization model. As you can see, we're going to make our display empty, so it's an empty string. Our function is just an empty anonymous function. our saved value is going to be 0 and our append is going to be set to true by default. Now we need to make a function that allows us to convert the strings of the display into a float value. This function is going to be called parseFloat. It's going to take in a string and output a float. Now we're going to use this result.withDefault because it allows us to set a default, and the default is going to be 0. So here we go. We're converting the string to float, and the input is going to be the value that we're converting to a float. Now the reason why we use this result with default is if we enter in, say, a plus or a minus or any other operator, it will not throw this off. Instead, it'll just count those as 0. Now, to deal with our actual operators, we need to make an operator function. Our operation function is going to take in the model, it's going to take in one of our anonymous operation functions, and it's going to output a model. Now, as you can see, all we're doing is we're assigning the operator to our function in our model here. We are changing the save value by parsing it from the model.display. So we're taking in the model.display if there is one. We're putting it through the parseFloat function, and then we're giving it to save value field. And then we're changing the append flag to false so that you can't add more numbers to this. So those are our two helper functions. Now we're going to get started with our update. So here's our type message. It's a union type. It has none, meaning if we input nothing, this is how it's going to handle it. It has divide for divide, times for times, minus for minus, add for add, equal to get us the result of whatever operation that we put in there. We have a decimal message, which is going to allow us to deal with if you hit the decimal button on the calculator. We have a 0 message, which allows us to deal with if you hit the 0 button on the calculator. And we have a number int message. Now this is going to allow us to render the number buttons for the calculator really easily, as well as call these number buttons. We also have a clear message, which is going to allow us to deal with the clear button on our calculator. So let's write our actual update function. As always, our update is going to take in a message and a model and output a model. Our first case, none, is just going to leave the model alone. Our second case is going to set the model equal to our init model. The reason we want to do this is we want to basically reset the state of our entire calculator by hitting the clear button. Our third case is going to take in an integer, and it's going to call a function called updateDisplay that we will write after this, and it's going to pass the model and number into it. This is basically going to let us deal with our number keys on our calculator. The next case is going to deal with decimals. It's going to pass the model into a decimal function that we have yet to write. Our next case, 0, is going to pass the model into a 0 function. Our next case, divide, is going to pass the model into the operation function that we wrote up here, and it's going to pass calculator.divide into the operation function as well. And that's going to go for all of our operation cases. Now, as you can see here, we have all of our operators here: divide, times, add, and minus. The only difference between these messages is which operator they're invoking. And then we finally have another case for our equal, and our equal case is going to send our model through an equal function. So let's write our updateDisplay function to deal with this case here. Our updateDisplay is going to take in a model and an integer, and it's going to output a model. So here's our updateDisplay function. Our updateDisplay function is taking model and number, and if the append is true, then we're going to pass the number into our model display, or rather we're going to concatenate it onto the end of our model display. So say, for example, our display is already showing 1 or 2 or 3, and we input 5, then we're going to create 35. This number is converted to a string before it's passed or concatenated to the model display. If model.append is false, the model is going to change the display to the number that we're putting in here as a string, and append is going to be set to true so that we can then add more numbers to it afterwards. Now notice I'm using these pipe operators. You can just wrap a number in parentheses and type toString before it if you want. All this is doing is making things neater. I like it that way, but it's up to you whether or not you want to use them. So the next function we're going to write is the equal function. It's going to take in a model and it's going to output the model. So here is our equal. Now our equal wants us to output what we've put into the calculator. So for example, if we hit 1 plus 2 times 6 and we hit the equal button, then we want to resolve all of these. So what we're doing is we're going to create a calculate function, which is going to allow us to apply the operators to whatever we have. So first what's happening is if model append is true, we're going to take the display and we're going to run calculate on the model. We're going to change the save value to our model display and we're going to change append to false. Otherwise, if append is already false, then the model is just going to equal the calculate model and append is going to be set to false again. So let's write our calculate function to better understand what's going on here. So our calculate function is going to take in the model and output a string. So our calculate function takes in the model, then it finds the model function, so the function that is being used by the model at the current moment. Then it takes the model last value and it applies that function to the last value and the model.display, which is whatever's in the display. And then it converts all of this into a string. So now we're going to write our zero function. This is going to take in a model and output a model. So here's how our zero function works. It checks to see if our model display is empty or model.append is false. And if that statement is true, then it assigns the display to the string of a 0 and it sets append to false. If that statement is false, however, then it assigns display to model.display concatenated with a 0. So what this is allowing us to do is it's either allowing us to write 0 as a single digit number, or it's allowing us to add 0 to the end of multiple numbers. So for example, if we put in a 5 first and we want to write 5,000, then we can hit 0 3 more times and it'll write 5,000. Now let's write our decimal function. Decimal is taking in a model and outputting a model. Here's our decimal function. It's going to check if the string is not empty. So if the display is not empty and model append is true, then, or is not true rather, then we can hit the decimal point, and what will happen is it will pass the model display through append decimal. If all of this is not true, then it will display a 0, and this is wrong, it should display a 0 with a decimal at the end. So there we go. It will display a 0 with a decimal end and change append to true. This way we can make decimals, so we could do 0.13567 just by hitting the point instead of having to hit 0 point whatever. So now we have to write an append decimal function. This is going to take a string and output a string. Now this function is of course appending our decimal to our number. So if we already have a decimal in the display string, then we're just going to display that string. Otherwise, if there is no decimal, then we're going to append that decimal to the end of the string. So that's it for our model. We have all the functions that we need to have a working calculator. Now let's create our view. So the first thing for our view, we need to make two functions. We need to make one function to handle our small buttons, and we need to make another function to handle our large buttons. So we're going to make a function called calculator button, which is going to take in a message and a string and output HTML message. This is going to create a button element, and as you can see, the button element is going to have a class of button and is going to have an onclick of the message that's being passed in here. And then inside of the actual button element, we're going to have a span element. And inside that span element, we're going to have a text of the button text that's being passed to this operator. So for example, for our button 1, it's going to have 1 as the button text, and on click it's going to allow us to invoke the number 1 message. So now I'm going to copy that function. I'm going to slightly change it for a wide button. The only difference for this button is we're going to have a class of button wide. So now we need to import our style sheet. So here's our style sheet function, and we're using a let-in binding to create an HTML node with these two lists inside of it. It's just going to be a node of tag type with the attributes inside the first list, and then the child list as our second list. Now let's write our view function. Our view function is going to intake a model, and it's going to output HTML and a message. Alright, so here's what we have first. We have 4 divs. The first div is going to be called calculator, so it's going to surround everything. And inside of it we're going to link our style sheet. Then we're going to have a div class of row, a div class of colon XL12, a div class of display, and a div class of display text, which shows the text as an HTML text message. Then we're going to have a div class of buttons, and inside this div class we're going to have our buttons. So here's what our clear button will look like. It's going to invoke the calculator wide button function, and it's going to pass the message clear and then a string of clear into it. Here's what our numbers will look like. As you can see, we're passing the number 7 message into this, and then the string of number of 7 into it. For 8 and 9, it's the same idea. For our divide message, we're just going to pass the divide message in here, and then we're going to pass the string that looks like divide. So now we just need to repeat this for the rest of our buttons. So now we have all of our numbers in here, and we have our divide, times, minus, and clear buttons. Now we just need our 0 button, we need our decimal button, we need our equal button, and we need our add button. Now here's our completed view. We have all of our different messages being passed into here, and we have all of the strings that go with those messages being passed in here as well. Let's check and see what errors we're having. For our calculate function, it was simply a mistyped variable here. For our update display function, it had to do with our pipe. Because we had our pipe, it was sending the model.display plus plus toString into our plus plus number into toString rather than just sending number into toString. Now it looks like everything else is complete. So here's our calculator. Now let's see if it works. So 1 plus 3 is indeed 4. We can append numbers, we can clear things. If we hit the decimal, it places a 0 in front of it. We can multiply things together. We can divide things. And we can subtract things. It looks like everything is working out here. I'm going to show you how to build this project. So we run elm-make on calculator.elm, and we want our output to be HTML. Specifically, we want it to be index.html. So here's our HTML file, and inside of it we have the core of Elm, as well as our actual built Elm project. Anyway guys, I hope you enjoyed this tutorial. Feel free to subscribe to our channel. Feel free to like and comment. And if you didn't like anything, feel free to throw up a dislike. I'm currently going to probably end up doing a Go tutorial after this. I have a vote going on Twitter. If you guys have any language that you'd like to see next, feel free to comment. Hope you guys have a good day.